Alright, hello everybody and welcome back. We're going to be continuing the Cimc, that's the intermediate paper for 9s and 10s. We're going to be continuing on. We just finished up question number 1. We're jumping back into it with question number 2, so let's take a look. Question 2, what is the smallest positive integer that is a multiple of each of 2, 4, 6, and 8? So we're looking for a number that is divisible by 2, by 4, by 6, and by 8. In fact, we're looking for the smallest such number. Okay, now there's a nice, quick, easy way of doing this, and it involves prime factorization. So let's take a look. So the prime factorization of 2, well, that's just 2 to the power of 1. Okay. 4, that's another one of our numbers. That's just 2 to the power of 2. 6, 2 to the power of 1, 3 to the power of 1. And 8, that's just 2 to the power of 3. Now, if we wanted to be complete and compare these all, what we would do is we would add in 3 to the zeros. That way we always have 2 to the something times 3 to the something for each one of our factorizations. So we're asked to find what amounts to the lowest common multiple. To find the lowest common multiple of a bunch of numbers who are written in prime factorization form, for each prime number, we find the highest exponent. Okay, so we're talking about finding 2s and 3s. So 2 and 3 are the prime numbers that are appearing amongst our prime factorization. We have 2 to the 1 times 3 to the 0, 2 to the 2 times 3 to the 0, 2 to the 1 times 3 to the 1, 2 to the 3 times 3 to the 0. So we're asked to, for each prime number, write down its highest exponent. So first prime number 2, okay, we have a 2 to the 1, a 2 to the 2, a 2 to the 1, and a 2 to the 3. 2 to the 3 is highest. So we write it down. Okay, our next prime number, and incidentally our last prime number, is 3. Well, what's our highest exponent of 3? We have 3 to the 0, 3 to the 0, 3 to the 1, 3 to the 0. So we're going to write down 3 to the 1. And this works with any sequence of numbers, any set of numbers. For prime factorizations, you can have more primes. You don't just need the 2. I'm writing each one of these down with the highest exponent that is presented in the list. You multiply those together. I mean, this gives the prime factorization of the lowest common multiple. So 2 to the 3, that's 8, times 3 to the 1, 24. So we found our lowest common multiple, and that's all the question asked for. So that concludes question number 2. Very straightforward question. Hope you enjoyed it. Hope you'll join me in the next video for question number 3.